Welcome dear students. Today we will be learning chapter number 6, heat transfer for ICSE class 8. Okay, so the name of the chapter is heat transfer. Okay, in this chapter we will be learning about the effects of heat on a substance. Okay, when the substance absorbs heat, what will be the effect on that substance, we will be learning in this chapter. Before going through the topic, let us revise what we have already learned in class 6 and 7. The states of matter. There are 3 states of matter, namely solid, liquid and gas. Okay, and they can change from one state to another state by addition of heat or by extraction of heat from them. So if we heat a substance, it may change from one state to another. If we take out heat from the substance, it may change from one state to another state. So let us focus on this liquid and gas. Okay, let us focus on this liquid state and gas state. Let us know, let us only focus on the transaction from liquid to gas, not from gas to liquid, but from liquid to gas. All right, so there are 2 ways in which this liquid can be converted into gas. Okay, there are 2 ways in which we can convert this liquid into gas. Number 1 is by boiling or vaporization. It is also called boiling or vaporization. Next is by evaporation. Okay, number 1 is by boiling or vaporization, number 2 by evaporation. By these 2 methods, liquid can be converted into gas. Okay, definitions and all you can learn in your book very easily. Out here I will be just explaining you. Okay, now boiling. Okay, what is boiling? Boiling is the process in which liquids get converted into gas at a constant temperature, at a constant temperature or fixed temperature. When we heat a substance, and if that, not substance, in this case liquid, when we heat a liquid and if that liquid converts into gas at constant temperature, it is called boiling. Okay, at normal temperature and pressure for pure liquid, for pure water, 100 degrees Celsius is our boiling point. At 100 degrees Celsius, pure water in normal temperature and pressure starts boiling, or it gets converted from liquid state to gas state. So this is about boiling. Let me finish everything for boiling now. Suppose this is a container and there is a water. Okay, we are giving the heat to this container containing water. All the molecules inside this liquid starts absorbing the energy which this heat is giving. Okay, this heat is giving energy, and all the molecules in this container starts absorbing that energy. Okay, and the temperature starts rising, and the temperature of this liquid starts rising. Okay, and when the temperature reaches 100 degrees Celsius, okay, if this is a pure water and under normal condition of temperature and pressure, the water starts converted into vapor. So this is called boiling. Okay, and remember one thing, boiling takes place through the entire liquid. Boiling takes place through the entire liquid. It is not a surface phenomena. Okay, so the liquid starts boiling, and the boiling takes place throughout the mass, through the entire mass of the liquid. Okay, now this is about boiling or vaporization. It takes place at constant temperature. Okay, by the absorption of heat. Heating is necessary for boiling. And are there anything which I have missed? No, it is a whole body phenomena. It's not a surface phenomena. Let me see if I have missed anything. It is a quick process. One thing which I forgot is it is a quick process. Okay, so I think this will help you in understanding boiling. Now let us go to evaporation. Evaporation is also the change from liquid state to gas state, but it does not need it does not require heating. Okay, heating is not required in evaporation. It takes place at any temperature. I have written TEMP, but it is temperature. Okay, it takes place at any temperature. Okay, it doesn't need any specific temperature to evaporate, and it is a slow process. It is a slow process, and the most important thing is it is a surface phenomena. Evaporation is a surface phenomena, means so evaporation takes place only through the surface. Suppose this is the container, I have kept this container outside. Okay, evaporation takes place only through the surface, not through the entire body, and it does not need heating is not required for evaporation. It's a very slow process. Okay, and it is a surface phenomenon. I think I have not missed anything now. Yeah, what are the effects of evaporation? You wash a cloth. Okay, you wash a cloth and you hang it somewhere. Okay, after some time you can see the vapor starts coming out from that cloth. Okay, so that is evaporation. And what is the result? The result is your clothes will become dry, isn't it? It becomes dry. Initially it was wet. When we washed it, leave it outside, the vapor will emit from that cloth. Okay, it will it will evaporate. Yeah, and it will become dry. So that is one effect of evaporation. Another effect, if you store water in a clay pot, okay, earthenware, it will cool. Okay, the water will remain cold. It is because of evaporation of water through the pores of that pot. Okay, and in a hot day, when you suppose you are walking or you are running on a hot summer day, and after you walk, your body will sweat, isn't it? Your body will sweat, and that sweat will evaporate. All that sweat will evaporate and your body will become cool. So sweating, after evaporation of sweat occurs, okay, after evaporation of your sweat, body sweat, your body will cool down. So it helps in regulating our body temperature also. It helps in regulating our body temperature. So these are the effects of evaporation, right? So the question for you all will be, question number 1, write 3 effects of evaporation. Question number 1, write 3 effects of evaporation. All right, now there's a difference. Okay, let us now understand the difference between evaporation and boiling. Number 1, difference number 1, evaporation can take place at any temperature. Boiling takes place at a constant temperature. Evaporation is a slow process, boiling is a quick process. Evaporation is a surface phenomena, boiling takes place through the entire mass of the liquid. Okay, these 3 differences should be enough. Other, you can write it yourself. It causes cooling, it does not cause cooling. Okay, it is a continuous process, it is not a continuous process. Boiling occurs as long as there is a heat and as long as the temperature is maintained. Okay, constant temperature is maintained. All right, this is all about evaporation and boiling. Now I have given you one question. Okay, our next topic is thermal expansion. All right, now we all know what is thermal. Okay, and we all know what is expansion. Thermal is related to heat. So the expansion of a substance on heating is called thermal expansion. The expansion of a substance on heating is called thermal expansion. Okay, so if I have a body, I heat the body. So for us, this is a symbol of heat. Okay, if we heat the body, this body may expand. Okay, so this is called thermal expansion. The expansion of a substance on heating is called thermal expansion, and thermal expansion occurs in solid, liquid and gas. If we heat solid, expansion occurs. If we heat liquid, expansion occurs. If we heat gas, expansion occurs. So thermal expansion is not specific to any matter, any state of matter, but it is for all solid, liquid and gas. The only difference is how much they expand. Gas expands the most, liquid less than the gas, and solid expands the least. These things you have to remember. Okay, this you have to remember. Which one expands the most? The answer will be gas. Which one expands the least? Solid. Okay, now let us understand the thermal expansion in solid. Okay, let us expand the thermal expansion in solid. How does solid expand? There are three ways in which solid expands, okay, on heating. Number one is called linear expansion. Linear expansion means along the length. Linear expansion means along the length. Suppose I have a body of length 5 centimeter. I have a body of length 5 centimeter. I heat the body. Now the body may become 6 centimeter. Okay, it is plus 1 centimeter. So 1 centimeter length is increasing. So if the length is increasing, the type of expansion is called linear expansion. Okay, if the length is increasing, it is called linear expansion. All right. Number two. After linear expansion, number two, we have superficial expansion. After linear expansion, we have superficial expansion. So superficial expansion means expansion of area. Okay, if the expansion occurs throughout the area, it is called superficial expansion. Suppose I have a plate. This is a plate. Okay, it has a certain area. If I hit this plate, the area of the plate may increase like this. So the whole area is increasing. In this case, the expansion is called superficial expansion. Okay, now this is our superficial, and the last one will be our cubical expansion. Cubical expansion means expansion along the, not along the, but expansion of whole body or the expansion of volume. If the overall volume of the substance changes on heating, or if the overall volume of the substance increases on heating, it is called cubical expansion. For example, suppose this is our cylinder. Okay, this is our cylinder. Let us heat. After heating, our cylinder may increase its volume. Okay, overall volume is changing. This type of expansion is called cubical expansion, where the whole volume of the substance increases. Okay, so there are three types, or the three ways in which the thermal expansion occurs in solid. Number one, linear expansion. Number two, superficial expansion, and number three, cubical expansion. Okay, I want you all to remember this. Okay, and you all can check a book. Okay, and there is an activity called, what do you call that, Graves-Sanders ring and ball experiment. Okay, the experiment related to bimetallic strip. You all can see that. Okay, now next, let us learn few examples of thermal expansion of solid. Okay, where this thermal expansion of solid comes into play, whether it is useful or it is just a theoretical topic, or does it have any practical application. Let us check. Okay, of course, since we are learning physics, okay, almost all the topic has practical application, or almost all the concept which we learn has some practical application. Okay, for example, let this be the wooden rim. I want to make a wheel. Let this be a wooden rim. Okay, let me draw this. And I have an steel ring of little small diameter. You see, bigger diameter, smaller diameter, and this is steel rim. Okay, steel rim, and this is wooden. I want to fit this steel rim in this wood. If I take this and try to put it outside, I cannot fit this. So what I have to do? I have to heat this steel rim. If I heat this steel rim, the volume of this steel rim, okay, overall, not volume, but overall dimension of this steel rim increases. Now what I'll do, I'll take this steel rim and place it above this rim. Okay, now it will look something like this. Suppose this is our rim. Now our steel rim will be somewhat like this. Now again I will cool this steel rim. Okay, now after cooling this steel rim, it will exactly fit inside this wooden rim. So this is how the wheel are made for carts. Okay, And there are many other applications which you can learn. Application of thermal expansion. Another one, railway lines. There's a gap, okay, there's a gap between two railway lines. The reason is when the train moves over these rails, okay, due to friction a lot of heat energy is produced, and these rail lines, they will try to expand, okay. But if there is no space for them to expand, the railway line may bend and it may cause an accident. So in order to avoid that, some space is left between two railway lines, so that when this railway line expands, there is some space for them to expand and the railway line does not bend, okay. This is another example. There are many examples you can check in your school textbook, okay. There are many examples. Another most common, suppose this is an electrical pole, okay, and this is another pole. During summer the wires are left loose, okay, they are kept loose. The reason is during summer season, okay, the wires, they may expand, okay, and they are loose. And in winter season, when the wire contract, so that it will fit, okay. Suppose in summer season, suppose we don't have the concept of the thermal expansion, we don't know what it is, and we try to fix it like this during summer season. This is how we have connected the wires between two poles in summer season, okay. And during winter season, when the winter season comes, the wire will try to contract, okay, because when the temperature decreases, okay, when the body is cooled, if the body is heated, they will expand, means just the opposite. If the body is cooled, they will contract. So in summer season this wire is already tight. In winter, when they try to contract, they will break. So in order to avoid this, the wires are kept loose between the poles in summer season, okay. So this is the reason. There are many others. I'll give you one last example, okay. You must have seen this, all of you have seen this. Suppose we have a glass, okay. Glass is a bad conductor of heat, okay. Glass is a bad conductor of heat, it does not conduct heat. So you pour hot water. When you pour hot water in the glass, what happens is, suppose I'll make it a little bit thick, okay. Alright, this is my glass. So when you pour water, okay, so the surface which is in contact with the water, they gets heated. The surface which is in contact with the water gets heated, and the one outside in a outer surface, the inner surface is in contact with the water and outer surface is not in contact with water. So what happens is, since this glass is a bad conductor of heat, the only inner portion will expand because of it, and the outer portion will not expand. Because of this, there is uneven expansion in the glass and it cracks. Now we have done about the expansion of solid. There is liquids also expansion heating, gases also expansion heating. For that, there are some experiments, okay, which you can check in a book. But the most important thing I have already discussed earlier, which one expands the most? Gases expands the most, okay. Just to prove, how to prove gases expansion heating, take a metal can, fix a balloon, okay, fix a balloon, make it airtight out here. Now heat this metal can. When we heat this metal can, the air inside this metal can gets heated and it expands, as a result of which this balloon gets inflated and it expands, okay. So this proves that gases also expands. To prove liquid expands, what you can do is, to prove that there is an expansion in liquid, what you can do is take vessels like this, okay. In one you put water, in another you put alcohol. Initially put equal amount, okay. There is water in this pot and in this vessel, there is alcohol in this vessel. Initially keep them in equal proportion, right, keep them in equal proportion. Now heat them. keep in mind that their initial temperature should be equal. Okay, now heat them. After some time you'll find that the water has expanded at this level till this level and the alcohol till this level. So there is uneven expansion. Alcohol is expanding more than water. Okay, so this proves that liquid also expands on heating. Right, so this is all. If you learn this much, okay, if you have understood this properly, what you can do is you can go through the book once, your prescribed textbook. You can go to the book once and again watch this video. If you have any doubt, again look at your book. Okay. So in this way, after doing it, repeating it 2-3 times, this chapter will be crystal clear to you. Hope this video will be valuable and helpful to you.